Hello
and
friends,
extended.
this video is
Now
brought to you
draw
by
a perpendicular from point P on the
www.moeteaching.com.
Say it meets y-axis at point R and the two perpendiculars intersect at point T. So now we have a right triangle PQT. Let us find the lengths of QT
L
and PT
and M are intersected by
Clearly,
a transversal
we know
P.
that PR is
Show
6
that the
units
quadrilateral formed
and
by the
RT
bisectors of interior
is
angles
5
is a
units.
rectangle.
So PT is equal
We
to
have
11
given that
units.
Line L and M are parallel.
Similarly, SQ
and transversal P
is 3
intersect
units,
them at point A
while
and C
ST
respectively.
is 4 units.
Let us mark the points
So
P
QT
and S
equal to
on L
3 plus
and
4 equal to
Q
7 units.
and R on
And
L.
now we can use Pythagoras theorem
Then
to find
bisectors of angle
PQ.
PAC and angle ACQ
We now come to the
meet at
derivation of distance formula for any 2 points.
and
Say
bisector
P
of angle
is x1 y1
SAC
and Q is
and angle
x2 y2.
ACR
Then
meet at point D.
to find PQ, we draw perpendiculars on the
And we
x-axis
have to
from
prove
P and Q
that quadrilateral ABCD is
and a perpendicular from P on QS.
Let us
Now,
recollect that by
PTSR
definition,
is a rectangle.
a rectangle is a parallelogram
We can find out
with one
RF,
of its
which will be
angle
equal to
90
PT.
degrees. So we will prove that
RS will be
ABCD is a parallelogram
OS
and
minus
we will
OR,
prove one of its angle is
but
90 degrees.
OS should be
So let us proceed with the
x2
proof.
and OR should be
We already know
x1.
that
Why? Because
angle PAC
coordinates of R
is
will
equal
be
to angle ACR.
x1 0
Why? Because
and
they
of
are
S will
alternate
be
angles.
x2 0.
So angle PAC
Similarly,
is equal to angle
we can find
ACR
QT
as
TS should
L
be
is parallel to M
y1
and these are alternate angles. This
So,
implies that half
QT
of
will be
angle
given by
PAC should be equal
QS
to half of angle
minus TS,
ACR.
that is y2 minus
That means
y1.
Angle
So we have PT now
BAC
and we have
is equal
QT.
to angle
It is
ACD.
now left to find PQ
Which
using Pythagoras theorem.
These angles.
Let us do so.
But these angles form
We get
alternate angles for lines
under root of
AB
x2 minus x1 whole square
and DC
plus
with
y2
AC
minus
as the
y1
transversal. So we
whole
can
square.
say that AB
Hence we
is
have derived the
parallel to
distance formula between points P and Q
DC.
if their coordinates are given to us, and it
Now,
is given by
similarly, if we
under root
consider
of x2 minus x1 whole
angle
square plus y2 minus y1 whole
SAC
square.
and ACQ,
In other words, if we have two
these
points
two angles will be
whose
equal
coordinates are known to us,
and hence their halves
just
will be
substitute in
equal.
the formula
And
and
we
find
can
the
prove
distance between them,
that
and no
AD
need to
is
follow the
parallel
whole
to
procedure.
BC. So
Distance
instead
formula
of proving
makes
in
things
this
very
slide,
easy for us.
Similarly,
In particular, if we have a point P whose coordinates are x and y,
AD
and we want to
is
find
parallel to
distance of point P from origin,
hence we have proved that both the pair of opposite
we
sides
can directly
for
use
the quadrilateral
distance
ABCD
formula
are parallel
which is
So
under root of
ABCD is a parallelogram.
x minus 0 whole square, that is x square, plus y minus 0 whole square, which is
Now
y
it
square.
remains to prove that one of the angles
This expression
of
by
the
itself
parallelogram
is a formula
ABCD
to find the distance of a
90
point
degrees,
whose coordinates are
and
xy
then
from
by
origin.
definition
So please
ABCD
remember
would
this
be
one.
a rectangle.
Let us read the question. Do the points
To prove
3,
that
2,
ABCD
minus
is
2,
a
minus
rectangle,
3 and 2,
let
3
us
form a
proceed
triangle?
by considering
If so,
angle
name the type of
PAC
triangle formed.
and
Firstly, let us name
angle
these points as
CAS.
P, Q and R. Now,
These two angles
P, Q and
form a
R
linear
will
pair.
form a triangle
So
if
angle
sum of distance between any
PAC
two sides of triangle
plus
is
angle
greater than the
CAS
third side.
equal to
So,
180 degrees.
we are required to find PQ
This would
QR
imply that
and PR.
half of angle PAC
We will use
plus
distance
half
formula
of
to find
angle
the length of the
CAS
sides of the triangle.
equal to half of
Also note that
180
while
degrees.
using distance formula, any point can be
half of
considered
angle
as
PAC
x1,
can be written
y1
as angle
and the
BAC,
other one as
so
x2, y2.
angle
Why? Because
BAC
we are using
plus
square of the
half of angle
difference between the
CAS
coordinates.
can be written
So
as
that will not make
angle
any difference.
CAD,
Let us use it here.
angle CAD
We get under
equal
root
to
of x2
90
minus
degrees.
x1 will be 3 minus of minus
but
2
angle
becomes plus 2
BAC
whole square
plus angle
plus
CAD
y2 minus y1
form
becomes
angle
2
BAD.
minus of minus 3, that is
So
2 plus 3 whole square,
we have
which gives us under
angle
root of 5 whole square
BAD
plus 5 whole square,
equal to 90 degrees,
which is equal to under
Which
root of
is
50,
one of the angles of the quadrilateral
which is
or
approximately
the
equal to
parallelogram
7.07. Similarly, we can
say
find
that ABCD is a
QR.
parallelogram in which one angle is 90 degrees.
say
Therefore,
I take
ABCD
coordinates
is a
of R as x2, y2, then it is equal to under root of
Let us read the question.
2 minus of minus 2, that
Show
is
that the bisector
2 plus
of
2 whole
angles
square
of a parallelogram
plus
form a
3
rectangle.
minus of minus 3, which is 3 plus 3 whole
We
square,
start with
and we
a
can find the
parallelogram
value.
ABCD and
Approximately equal to
PQRS
7.
be the points
21.
of intersection
Also
of
find
the
PR.
bisector of angle A,
For that, say
angle B,
my
angle
point
C,
R is x1,
and
y1
angle D respectively.
and P is
That
x2,
means
y2.
we already know that AP is the
Then PR is equal to
bisector of
under root
angle
of
A, BP is
3 minus 2 whole square
bisector of angle B,
plus
CR is
2 minus 3 whole square,
bisector of angle C, and DR
which is equal to root
bisector of
2,
angle D.
that is approximately 1.41.
We have to prove that PQRS is a rectangle.
From the distances that we have
That means
calculated,
by
we can see
definition
that
we have to prove that
sum of
PQRS
any two
is a
sides
parallelogram in which one
is
angle
greater than the third
is
side
90 degrees.
for all possible combinations.
We can start the proof by saying that angle A
If we take PQ plus PR,
angle D equal to 180
it is also
degrees.
greater than QR,
Why? Because
and
angle
QR
A and
plus
angle
PR
D are
is
the
greater than
interior angles
PQ.
on the same
So we
side of
can
the
say
transversal.
that the given coordinates
Then
PQR
half
form
of
a
angle
triangle.
A
Now
plus
it remains
half of
to
angle
find
D
what type of a triangle it is.
will be equal to half of 180 degrees.
From the figures under the root, clearly we can see
half of angle A
that PQ whole
can be
square
written as
plus
angle
PR whole square
DAS. So angle DAS
is equal to
plus
50 plus 2,
half of angle D
which is
can be
equal to
written as
52,
angle
which is equal to
ADS.
QR whole square,
So we write it as angle
which implies
ADS
that PQR
equal
is
to
a right
90
triangle.
degrees.
So we write, by converse of Pythagoras theorem,
Let us mark this as 1.
PQR is a right
And now
triangle.
consider
Please read
triangle
the question.
ADS. In this triangle, sum of the angles will be 180 degrees. So we have the following equation. This angle plus this angle plus angle DSA is 180 degrees. From 1, let us substitute angle DAS plus ADS equal to 90. So we have 90 degrees plus angle DSA equal to 180 degrees. On solving further, we get angle DSA equal to 90 degrees. So we have angle DSA equal to 90 degrees, which will imply that angle PSR equal to 90 degrees, as these are vertically opposite angles. Hence we have proved that one of the angles of the quadrilateral PQRS is 90 degrees. Also note that the way we have proved that angle PSR is 90 degree, similarly we can prove that angle PQR is also 90 degrees by considering angle C and B. So we will write similarly angle PQR is also 90 degrees, and we can also prove that angle R and angle P are also 90 degrees by considering AD parallel to CB. So angle C plus angle D should be 180 and halves will be 90, and that would imply, by considering triangle DRC, that angle R will be 90, and similarly we can also prove that angle P is 90. Let us do one proof for you. We have angle D plus angle C equal to 180 degrees, as AD is parallel to BC and DC is the transversal. Then angle D and angle C are the interior angles
Hello
on the
friends,
same side
this
of the
video is
transversal.
brought to you by
And this would imply that half of angle
www.moeteaching.com.
D plus half of angle C equal to half of 180 degrees, that is 90 degrees, which would imply that
Let us read the question.
CDR
The figure shows
plus
the arrangement of desks in the
angle
classroom.
DCR
Ashima, Bharti and Kamala are
equal to
seated
90
at A,
degrees.
B and C respectively. Do you think they are seated
Then
in
we
a
will
line?
consider
Give reasons for your answer.
triangle
This question is basically
DCR
to prove that point
and
A, B
we will
and
have
C are collinear.
angle
The condition for which will
CDR
be that if AB plus
plus
BC
angle DCR
equal to AC,
plus
then
angle
points A, B and
DRC
C are collinear
equal
points.
to 180 degree by angle sum
Let
property.
us calculate AB
and then we will
using
substitute from
distance
here
formula,
and
which will
get
be equal to under root
90
of
degrees
x2 minus
plus
x1, that is
angle
6 minus 3
DRC
whole square,
equal
plus
to 180
y2 minus
degrees.
y1, that is 4 minus
On
1 whole
solving, we will
square,
get angle
is
DRC
equal to under root of
equal
9
to
plus
90
9,
degrees. So
which
we
is
will
equal
have
to root of
angle
18,
R as
which is
90 degrees.
3 root 2.
And similarly, we can prove
Similarly, calculate
angle
BC
P
and
also equal
AC.
to 90 degrees. Let us recollect
It's time to calculate
that our theorem
AB
number
plus
5
BC,
said that if in a
which is equal
quadrilateral
to 3 root
each
2
pair of opposite angles are
plus
equal,
2 root 2.
then it is a parallelogram.
We can
So
take out root
hence,
2 common,
in
and we are left with
PQRS,
3 plus 2 in the brackets.
opposite angles are
And
equal.
We get 5
So,
root 2,
PQRS
which is equal to AC.
is a
Now since
parallelogram
AB plus BC
in which
equal
one
to
of the angle
AC,
is 90 degree,
hence we can say that the 3 points are
hence we
collinear,
can say that
which implies
PQRS
that
is a
children are
rectangle.
seated in a